So now let's see how to draw wavefronts for refraction from denser to rarer medium. Okay, so let's make this surface a little bit slanting so that it can appear confusing to some students. So this is the interface. Interface is the boundary between the two medium of different refractive index. So this side is denser, incident medium, and this side is rarer. Okay, now let's make plane wavefronts. So plane wavefronts are, let us say, coming like this. So first let me draw the incident ray. So this is the incident ray. So the plane wavefronts have to be perpendicular to it.
So you use a set square.
It's okay, roughly I am doing. So let me make the wavelength 1 centimeters. So I can extend the incident ray further.
By dotted.
Yeah, by dotted lines. So that I can draw more wavefronts. So now these are the points of incidence of the wavefronts at which I have to draw the refracted wavefronts. So incident ray is here. So next step is draw the normal through the point of incidence.
And bends away from the normal.
Yes. So normal has to be perpendicular to the interface. So I use a protractor. Okay, so normal we have drawn to the point of incidence. So the angle of incidence is this, and the refracted ray. So the incident ray, this is the incident ray. It should bend away from the normal. So this is the original direction. It has to bend away from the normal like this. So let's draw the refracted ray in red.
We can draw it at any angle.
Yeah, any angle. If you know the refractive index and angle of incidence, then you can always calculate the angle of refraction. But if not, in such diagrams, they are just shown it's diagram, so it has to be bending away. By how much it doesn't matter. So instead of going like this, it will go like this. So draw it like this, and behind it you draw it in dotted line. So this is a refracted ray. Now you have to draw perpendiculars to reflected ray in order to get the wavefronts. So perpendicular has to pass through these points. So after drawing one wavefront, the remaining you can draw parallel to it. So the refracted wavefronts should be only on the other side of the medium. Now the next one is parallel to this.
Wavelength will be same.
Wavelength has become
Will be
bigger
big-
now.
Yeah, it'll change.
Because in a rarer medium it will travel faster,
Ah.
so it will cover more distance at the same time. So wavelength becomes bigger. Okay. This is it. These are the refracted wavefronts. Refracted wavefronts. Clear?